Right, so we're going to graph the following vector u. It's given in component form, so the pointy brackets tell us component form, -4, -6. First number is going to be the x component, that's the sideways horizontal component, and the -6 will be the y component or the vertical component. So you notice underneath the graph, actually, are some important hints. Here's the drawing tool. It's automatically selected the vector drawing tool. It's already there for us, but you can see that there are two red dots on there. Those are the kind of like directions for how to draw a vector. So we're going to make one click at the starting point, the initial point of our vector, and then we're going to make a second click on the graph at our terminal point or where we want to end. So I'm going to start at 0, 0, move my cursor to 0, 0, make a click, and then you can see as I move my mouse around, that is just going to follow my cursor around. So I want to make sure I get it into the correct position first before clicking. And this obviously is not the right location, but you notice that it will click in between whole numbers. So we want to make sure that you're actually on the correct location and not just kind of close. So -4 is going to go left 4 spaces. The -6 is going to go down 6 spaces. Once I get my cursor in the right place, go ahead and click, submit, and hooray! That's right. Nice. All right, so part two gives us that same vector and now asks us to find the magnitude of the vector. So that's the length. And our magnitude formula is basically the Pythagorean theorem, but it's been rewritten to use vector notation. So the vector u, magnitude, looks like those absolute value symbols. It's the square root of a squared plus b squared, where a and b represent the x and y components of the vector. So I am going to take that -4, square that. So I'm going to take that -6, square that, add them, square root, and it's going to be the magnitude of vector u. So 4 squared, that is 16. 6 squared is 36. Whoops, 36. And I'm going to add those two together, which will give me, is that 52? Uh, okay, so the square root of 52. The directions say I can use exact form. That would mean radical 52. Or I can round my answer to 2 decimal places. I don't even have a calculator out, so I'm not going to round to 2 decimal places. Here's what this is going to look like to get this typed in here using exact form. So when I click into this answer box, toolbar pops up. And so the easiest way to do this is just select the square root symbol and then just type the 52 right in there. Before I hit submit, let me show you. Here's another option. Some people, would rather use keyboards that's their preference. So you can type SQRT. It's kind of like the first two letters of each word, except not. Anyway, SQR, and then watch when I hit the T, it's going to magically change into the radical symbol, and then I can put 52 right in there, hit enter. And that is correct. All right, last part asks us to find the direction angle in degrees in which the vector points measured counterclockwise from the positive x-axis. So I'm going to do this problem twice to illustrate two different approaches, but I want to make sure that we get direction angle, always, always, always measured counterclockwise from the positive x-axis. All right, so I'm going to mark that onto my graph. So here's the positive side of the x-axis. So the first thing I did was I drew a right triangle using the two components, the x component and the y component, as the legs of that right triangle, and the resultant is the hypotenuse. So we've got -4 is the adjacent side, -6 is the opposite side. I've named both of those sides based on my imaginary stick person, my graph walker, standing at the origin. Okay, so I set up my tangent ratio, -6 divided by -4. Inverse tangent of that ratio gave me an angle of 56.3 degrees. Okay, that 56.3 degrees is not the final answer. That's the angle inside this triangle, right? But the direction angle does not start from the edge of the triangle. Direction angle starts from the positive side of the x-axis. So to get to this, where that vector is, we would have to rotate from the highlighted side of the x-axis all the way around the counterclockwise direction, past this first side of the triangle, and then all the way to the resultant. Okay, so the part that's inside the triangle, that's 56.3 degrees. but that's measured from this first side of the triangle. That first side of the triangle coincides with 180. And if I was to start at the positive side of the x-axis and just go halfway around to where that first side of the triangle is, the first place I hit in the triangle, that's 180. So I'm going to take that 180 degrees, and then I'm going to add to it the 56.3 degrees. That'll give me my final direction angle, 236.3. Okay, just to help make that a little bit more clear, let's look at that another way. What if I had drawn my right triangle oriented a little bit differently? What if I go down the y-axis with my -6 first and then my -4 across? So from the perspective of my little graph blocker at the origin, now the -6 is the adjacent side, opposite side will be -4. So those are switched around because I drew it differently. So I set up my tangent ratio again, -4 divided by -6, do the inverse tangent, I got 33.7. That 33.7 is still the angle that is inside the triangle. Okay, so direction angle is measured from the positive side of the x-axis. So that's the rotation I'm looking for. Okay, so this time the side of the triangle that I've measured from is a larger rotation. Right, I'd have to go past the hypotenuse all the way to the adjacent side. That edge of the triangle coincides with 270 degrees direction angle, right? So one of the sides of the triangle is always going to match up with one of those four cardinal directions: 0, 90, 180, 270, or 360. That's where I'm working from. So in this case, the straight down side of my right triangle is at 270 degrees, but that would be too big of an angle, right? I have to, if I'm going past this, if I'm following the red rotation to get all the way to that angle, I've gone too far because I went past where the hypotenuse is, which means I need to back up or subtract. So I'm going to take the 270 and subtract this 33.7, that's the angle inside the triangle. 270 minus 33.7 gives me that same answer in the end, 236.3.